Hello students, in today's class we will see a second order system's response to unit step input, right. So before going into the response, let us see what is the standard form of a second order system. For a second order system, the transfer function is given by C of s by R of s is equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. This is s to the power of 2. So it is a second order system. Here we have two unknowns. What is omega n? Omega n is nothing but undamped natural frequency. Undamped natural frequency units radians per second. And zeta is called as the damping ratio. As it is a ratio, it doesn't have any units. Okay. So for this second order system, we will see how the response will be when it is applied a unit step input. So we know that C of s is equal to R of s into omega n square divided by s square plus 2 zeta omega ns plus omega n square. Okay. See, this natural frequency, undamped natural frequency of any system will be the same, but this damping ratio can be varied. Okay. Depending on the value it takes, the response will vary. For example, consider zeta equal to 0. When it is equal to 0, there is no damping. What will happen if there is no damping? See, originally the system has oscillations. We can see because it has an undamped natural frequency, the system naturally oscillates. It has an oscillatory response. Okay. For that only we are introducing this damping ratio. If the damping ratio is not there, what will happen to the system? So there are various cases for this second order response, okay, based on the value of zeta. Today's class we will see when there is no damping ratio, when zeta is equal to 0. Okay, that is an undamped system. So when the zeta is equal to 0, it is called as an undamped system. Okay, for an undamped system, when we apply zeta equal to 0, what will be C of s? C of s is equal to R of s into omega n square divided by s square plus omega n square. Right? Since zeta is equal to 0, 2 zeta omega ns term will get vanished. Okay. We know that we are going to apply unit step input, right? So R of s is equal to 1. So C of s is equal to 1 by s. R of s is equal to 1 by s. Right. So C of s is equal to 1 by s into omega n square divided by s square plus omega n square. So what happens? Omega n square divided by s into s square plus omega n square. Right. So how to go about this? We have to split the equation using partial fraction method. So C of s is equal to omega n square by s into s square plus omega n square is equal to a by s plus bs plus c divided by s square plus omega n square. Right. So what will happen? Omega n square is equal to a into s square plus omega n square plus s into bs plus c. Right. So what will happen? Omega n square is equal to a s square plus A omega n square plus B s square plus CS, right? Equating the coefficient of s square, s and constant on both sides. What do we get? Equating coefficient of s square, we get a plus b is equal to 0, right? So which means a is equal to minus b. See, here we don't have any s square expression, whereas this side we have s square expression, a s square plus b s square. So what is the coefficient of s square? A plus b, and this side it is 0. So, right? And now what happens when you equate the coefficient of s? See, s coefficient here is just c, right? And this side it is 0. So we get c is equal to 0. Okay. Then equating coefficient of constant. Here omega n square is the constant. And what about that side? We have a. A omega n square is the constant. So which means a is equal to 1. Right? And we know that a is equal to minus b. So what is b? Since a is 1, b will be minus 1. Right? So what will be the final expression for CFS? CFS is equal to 1 by s, right, plus bs plus c. What is b? B is minus 1 and c is equal to 0. So it is minus s by s square plus omega n square, right? So what is C of t? C of t is equal to Laplace inverse of C of s, which is nothing but, for 1 by s, Laplace inverse is 1, and for s by s square plus omega n square, we know that it is cos omega n t, right? So it is cos omega n t. Okay, so this is the final expression. C of t is equal to 1 minus cos omega n t. Okay, what will be the response without any damping ratio when zeta is equal to 0? See, we know that cos omega t response is nothing but, I'll draw it here. We know that cos omega t response is nothing but this, right? This is cos omega t. Now we have 1 minus cos omega t. What will happen? 1 minus cos omega t means, I'll just so this is the 1. So what will happen? 1 minus cos omega n t is nothing but, this is 2. This will be the response. Okay, so it will be a completely oscillatory in nature, right? So the response will be completely oscillatory. So this is what is the C of t.